of rose plant is growing in a garden in such a way that the number of plants is growing exponentially. The number of plants n in the garden at time t is modeled by the function n of t equals a times b to the t power, where a and b are constants and t is measured in months. The table shows two values of the function. Write an equation that can be used to find the number of plants n in the garden at time t. Which equation can be used to find the number of plants in the garden at time t? So we have multiple choice. I didn't mean to write there. I was just trying to scroll. We have multiple choice, and we have numbers in for a and b for the equation. So let's just write the equation down here and remember the form of an exponential function. N of t equals a b to the t power. Okay, when we look at it in exponential function like this, you know that the a would mean the initial value, the starting amount, and that's the number when time t equals 0. And then what's b? B is the constant factor, the number that we are multiplying by again and again and again. Okay, so that's just a review of the basic form of an exponential function. So now looking at this specific set of values, what's the initial value? Well, if you said 75, that's right, because at time 0, the output is 75. That's the initial value. So initial value of 75. So we can eliminate choice B because the initial value is not 300. We can eliminate choice D because the initial value is not 300. And then we want the factor. So we want to figure out when we get from this output to the next output, what number do we multiply by? So if you're not sure, think of dividing, right? You can put it in your calculator. I'll have a calculator on the midterm. You'll do 300 divided by 75, and you'll see 4. That means that 75 multiplied by 4 is 300. So 4 is our factor. So choice C is correct because it shows the initial value, starting amount of 75, and the factor, the number we multiply by, is 4.